Have you ever stopped at a gas station and wondered where that fuel actually came from? It starts as thick, dark crude oil pumped from deep underground, yet somehow ends up as the clear gasoline, diesel, and jet fuel that power cars, trucks, ships, and airplanes around the world. It might seem like oil is simply cleaned and poured into different tanks. In reality, it undergoes one of the most complex industrial processes ever developed. Let's uncover how it really works, right here on Simply Understood. The journey begins at an oil refinery, a massive industrial facility filled with towers, pipes, tanks, and reactors that operate around the clock. Crude oil isn't a single substance. It's a mixture of thousands of different hydrocarbons, molecules made primarily of hydrogen and carbon. Some are small and light, while others are large, heavy, and almost tar-like. Before refining begins, the crude oil is cleaned to remove water, salt, and tiny solid particles that could damage equipment. It is then pumped into a furnace and heated to around 350 to 400 degrees Celsius. At this temperature, much of the oil turns into vapor, while the heaviest parts remain liquid. The hot mixture enters one of the refinery's most recognizable structures, the distillation column. This tall tower separates the crude oil according to the boiling points of its different hydrocarbons. As the vapor rises through the column, it gradually cools. Heavy molecules condense first and collect near the bottom, while lighter molecules travel higher before turning back into liquid. This single step separates the crude oil into several useful fractions. Heavy products like bitumen remain near the bottom and are used for roads and roofing. Above them are lubricating oils and waxes. Higher still come diesel and heating oil, then kerosene, which is refined further into jet fuel. Near the top of the column are gasoline components, and at the very top are light gases such as propane and butane. But simple separation isn't enough. Modern society uses far more gasoline and diesel than crude oil naturally contains. To meet demand, refineries must actually reshape many of the heavier molecules. One of the most important processes is called catalytic cracking. Heavy hydrocarbon molecules are mixed with a powdered catalyst and heated until they break apart into smaller, more useful molecules. Instead of simply separating what's already there, the refinery is chemically transforming the oil into products that didn't exist in the original crude. Other units perform the opposite job. Some combine small molecules into larger ones that are better suited for high-performance fuels. Processes such as reforming rearrange the structure of hydrocarbons, improving gasoline so it burns more efficiently and resists engine knocking. Throughout the refinery, sulfur and other unwanted compounds are also removed. This is especially important because sulfur in fuel contributes to air pollution and can damage modern vehicle emission systems. Hydrogen is often used during this cleaning process to convert sulfur compounds into hydrogen sulfide gas, which can then be safely removed. After all these treatments, the different fuel components still aren't ready for sale. Gasoline, diesel, and jet fuel are actually carefully blended from multiple refinery streams. Engineers adjust the final mixture to meet strict standards for performance, emissions, seasonal temperatures, and engine compatibility. The gasoline you buy in winter may have a slightly different composition than gasoline sold during summer because it needs to evaporate differently in changing weather conditions. The deeper story is that an oil refinery isn't simply a giant filter. It's more like a chemical factory. Nearly every major processing unit is changing molecules, breaking them apart, rearranging them, or combining them into entirely new products. A barrel of crude oil isn't divided into finished fuels. It is continuously transformed into the products society needs most. And fuel is only part of the picture. The same barrel of crude oil can also become plastics, synthetic fibers, detergents, solvents, cosmetics, lubricants, asphalt, and countless other materials used every day. Transportation fuels may receive the most attention, but they're only one branch of a much larger chemical network. The next time you fill your car with fuel, it's easy to think you're simply buying refined oil. But every drop has already passed through an extraordinary journey of heat, pressure, chemistry, and engineering. It's a reminder that one of the world's most familiar liquids is actually the product of one of humanity's most sophisticated manufacturing systems.